Hi viewers, you're welcome to another episode of Staad Pro. In this episode, I'll be showing you how you can design a Raft foundation in Staad Foundation. Alright, so this is a building that has been modeled and then analyzed. We can check the, you can see it in the rendered view. So this is how the building looks like. And then if you try to check the post-processing, you'll see that we have the analysis ready. Okay, so you can check the results, but that is not our concern. The concern is to design the foundation. So I can go to foundation design. Alright, then I'll be using all supports. All the supports will be included in designing the Raft foundation, so make sure this is selected. Then I can now take all of my load cases from the available, I can take them to the selected. So just click on include all, and then I can run Staad Foundation. Alright, so here we are in Staad Foundation. You can see our support. This is the first one. This is 1. You can see this is 2, this is 3, and then the last one is 156. Okay, so those are the points. We have the supports. So the first thing you can do is, probably you may want to create a project info, so you can create all that, but I will just move to the load and factors. So what I'll be doing right here is I will just generate my load combination. So click on create load combination. So here I have two tables. The first one is for the service load, and then the bottom one, that is for the ultimate. So I'll pick the code template, which is British. So when you are done doing that, click on generate load combination. So that has been created. You also do the same thing for the ultimate load, and that has been created. So you can close now. So that is perfect. If you are done doing that, go to job setup, and then you can create a new job. Okay, I have to give the job a name, so let me give it Raft Foundation. Okay, that is perfect. Then job type, make sure that is matte is still Raft. So the design code, that should be British. So when you are done doing that, make sure you import all of the load from the available and get them to the selected. So I'm taking all of them, and then I'll create the job. So the load has been created. You can see I have my matte foundation, so you can open that, and then just follow the step. Go to the default properties. So all you need to do is you have to make some changes. So you can see the thickness of the slab. You have two. You have the analysis and you have for the design. You can make the two to be equal. So the thickness of the slab, I can make that to be 300. 300 is not bad. Then the unit grade of soil, the subgrade, I can make that to be around 18,000 kilonewton per meter squared. So, and then the density of soil 22, that's not bad. And then you can see we have the beam sectional property. This is the raft beam. When you say raft foundation, it consists of the raft beam and the raft slab. So I want the raft beam, the depth of the raft beam, that should be the same as the depth of the foundation. So I want that to be, let's say, 1200 mm, and then the width, let the width be 230 mm. Okay, yeah, 230.000. So you can leave all this, and then you can go to physical beam table. So this is where you are going to create your beam. So let's see, let's say we want to have a beam. You can see this is point 1, right? So we want to have a beam from point 1 down to point 6. Okay, so you, for node A, just put 1, and then node B, put 6. Let me try to expand this. Alright, then the depth, you don't need to fill anything, just come here, it will automatically fill it. So that is perfect. You can see the beam has come to that side. You can now see the beam there. Alright, so I want to have another one from this point. You can see from node 1 up to node 151. So you just put 1, and then this side you have 151. Okay, so you can see you have the beam. Okay, let's have another one from node 6 up to node 156. So 6, 156. Alright, so we have another beam. Let's have another one from 2 to 152. So 2 to 152. Okay, perfect. We can have another one from 3 to 153. 3 to 153. Okay, we can have another one from 4 to 154. 4 to 154, right? And then we can have another one from 5 to 155. So I have 1 5, and then we can have 155. Just insert the position of the node. Then we can have another one. Let's say we have another one from 151 to 156. 151 and then 156. I can also have one from 61. Let's have from 61 to 66. So have from 61 to 66, and then I can have from 91 up to 96. 91 up to 96. All right, so I have all of the raft beam. You can see all of the raft beam are here already. So I have to create the raft slab. So click on mesh, and then you can now go to add rectangular region. Okay, so I want my raft slab to be protruding by 230. Okay, so it will exit this raft beam you are seeing by 230. But before I create the rectangular region, you should pick a particular point which will be your where you want to start from. So let's assume I want to start from point 1 here. So let's try to confirm the position of the point 1 so that you can know the position. To know that, you can go to foundation plan, and then you say column position. So for column 1, this is column 1, alright? This is column 1. So for column 1, you can see that the position on X is 0, position on Y is 0, position on Z is 0. Okay, so that is perfect. So now if I want to have a raft slab, if you want to have a raft slab on this particular portion, if you want the boundary of the raft slab to be exactly where you have this, so under the rectangular region, you just put 0 here, put 0 here. Okay, however, I want my slab to go outside by 230. Okay, so that means I will have something like minus, let me change this to mm first. I will have minus 230 mm. Also here I will have minus 230 in the Z direction. Okay, then it's asking what is the length of the building. So let's go back to Staad Pro to confirm that. So the length of the building, let's pick this one and then measure the length of the building. That's 25 meter. So you have to add it to 230 and then 230 in the other side. So that's 25 meter. That's 2500 plus 230 plus 230. That should be 25,460. Okay, so let's insert that. So the length will be 2960 in mm. Okay, then what about the width? You can also do the same thing for the width in Staad Pro. Confirm the width. So from this point, we can measure it from the bottom to avoid confusion. So pick it and then measure from here up to here. Okay, so that is 15 meter. 15 meter plus 460 again, that will give us 15,460. So we can insert the width to be 15,460. all right. So if you are done doing that, you just click on add region, then the region will be added automatically. So you can see the region, that's what you are seeing in this color. So if you click on it, so this is the region. Okay, so that is perfect. Now all I need to do is I have to generate a mesh. So to do that, you go to under the mesh generation, you can now go to meshing setup. Okay, so to generate the mesh, you have to select the boundary, which is this one. Then you give it a name. Let me give it mesh. That's identifier name. So you click on add. All right, then you can now select the mesh here, and then you can generate a mesh. But you have the right to define how much you want the mesh to be. Let me put this in mm. So I want it to be 100 mm, 100 mm meshing. So generate that, and then quadrilateral meshing. Okay, so let's wait for it to generate the meshing. Alright, the meshing has been done. You see that the meshing is very finite. You can see how tiny it is. Okay, so to save your time, you might make it to be bigger, maybe 200 mm or 250 mm. Okay, so I'm done with the meshing. So after the meshing, what you can do is you just go to analysis and property. So your slab thickness, the default is here, which is 300 mm. Let me change this to 250, which is 0.25, and then let me make this to be 0.25. all right, so that's for the analysis thickness and the design thickness. Then you can work with your soil property. So click on use soil property, and then the subgrade, I've changed this to 18,000 earlier. So, and then soil height. So soil height, that is the foundation depth. So let me make that to be 1,200. Okay, sorry, that's a meter, so that should be 1.2 meter. So that's the same thing I use for my height of the that's the same thing I use for the depth of the raft beam. Okay, so when you are done doing all that, the next thing to do is you just go to maths slab analysis / design. So you click on analyze, so that you can analyze the building. Then you click on yes. Alright, so you can just lift this up, just lift it up a bit. Then you can scroll down. Alright, you can, then you see yeah, you can see analysis completed. So the analysis has been completed. So you can check your displacement. Just take this up a little bit. Let's take it up more. Okay, so you can check your displacements. You can check your a lot of things. In fact, you can check your plate stress. Just check everything. But to check it more perfectly, you can go to output view option. Okay, so output view option, then you can, if you want to see for the beam, let me zoom in. So if you want to see for the beam, you can just click on show beam stress. All right, then you come here. So if you want to see the bending in the Z, okay, so you do that, then you can see your beam. So you can see your raft beam. All right, so you can see the height, and then you can see how the stresses are with the color. So that is your beam stress. If you want to check for the plates, click on show plate stress. Okay, and then you pick the particular one you want to check, if it is the maximum, absolute, or something. All right, so just check that. All right, so you have everything ready here. Okay, so if that is fine, you can go to design parameter. So we've analyzed it, but we've not designed it. Okay, so you can go to design parameter. Then under the design parameter here, you can now change your your FY, that is the grade of your steel. I would prefer to put this in 460. My FC, yeah, that can be 30. Let me put that in 30 instead of 35. I think 30 is enough. Then the top cover, let me use 40, and the bottom cover as well, let me use 40. Okay, then the minimum reinforcement, I want to use 12, and then the maximum 20. All right, maximum be 20. Then the spacing, the maximum spacing 500, minimum spacing 500. So that's not bad. Then you click on design. Then you can see design processed. So the design has been processed. Then you can click on OK. All right, so when you are done doing that, you can just check your calculation sheet. So click on calculation sheet, or you may even click on result summary from here. So here you go, you can see design of mat foundation. Then you can just check through and see everything you have. So you can see your calculations. So everything is here. If you want to print it out, you can actually print it out. All right, so you can actually go to details report here under the design parameter. Okay, when you're done doing that, you can click on detail reports. So you will see you can see your reinforcement, your longitudinal reinforcement, and you also have the transverse reinforcement. Okay, you can see your longitudinal reinforcement. So when you check that, you can just check your area provided. So the area provided is 325 mm. Okay, so that is the area provided. So now when you want to detail, you have your steel table ready. So you can now check your, so you can now look for the appropriate spacing that will befit this area of spacing. So this is the data you will use to, detail your reinforcement. Okay, so for the transverse as well, you will see what you have here. Okay, then for the side bars, so you can see your top reinforcement, and then for the bottom reinforcement. So this is basically everything you have to know as far as Raft Foundation is concerned. So we've come to the end of the design of Raft Foundation. If you like this video, make sure you give it a like, and if you haven't subscribed, kindly subscribe to my YouTube channel. Thanks for watching.